Assalamualaikum everyone. Today we are going to start a new lesson which is electrolysis chapter number 15. So today we will discuss about electrolysis, like what is electrolysis, how it is work, and electrolytic cell. And then we will discuss about the parts of electrolytic cell. After this we will discuss about the electrolysis of molten ionic compounds. Let's start. First of all, what is electrolysis? So, electrolysis is the process of using electricity to break down or decompose a compound, usually an ionic compound, in the molten state or in the aqueous state. So, in electrolysis, we use the electricity and pass through the liquid, then we will check what happened. So, electrolysis is used to extract and purify metals. There is the electrolytic cell. So here we use the liquid and we pass the electricity, then we will check what happened in this cell. So here is the electrolytic cell, parts of electrolytic cell. The very first part is electrolyte, and there are two electrodes. One is anode and the second is cathode. And we also use a battery to join this electrodes. So, what is the role of this battery? Actually, it acts as an electron pump. Anode becomes positively charged. Electrons pumps out and move from anode to cathode. Electrodes. Electrodes, there are two electrodes. One is anode and second is cathode. So in the battery there are two terminals, positive and negative. These positive terminals, this positive terminal attached with anode and the negative terminal always attached with cathode. So it helps to conduct electricity from the solution. Usually carbon rods and metal plates. These electrodes are usually made with carbon and metal plates. So connected to the positive terminal is known as anode and connected to the negative terminal is known as cathode. That is the last part of the cell, which is electrolyte. Electrolyte is a solution actually which we use in this cell. So basically this liquid conducts electricity. Why? Because there is a free moving electrons or ions which allow electricity to move through. Ionic compound is decomposed and form positive ion and negative ion. If we use ionic compound in this solution, then it is converted into positive and negative ion. Here is some example of electrolyte, which is sulfuric acid, sodium chloride, and copper sulfate. The next term which is present in your book is what are known electrolytes? What are non-electrolytes? So non-electrolytes is a compound that does not conduct electric current in either aqueous solution or in the molten state. It means non-electrolytes are such compounds which don't have free ions or electrons. That's why they never pass electricity through them. So many molecular compounds such as sugar or ethanol are non-electrolytes because free ions and electrons are not present in sugar molecule and ethanol. What are the difference between metallic conductors and electrolytic conductors? So how elements actually and the compounds conduct electricity? Elements which is present in our periodic table and we cannot decompose it in chemical reaction. But compounds, many elements form together, combine together and form a new material which is a compound. Let's see how electricity passes through metallic conductor and electrolytic conductor. Metallic means metal. So metals have some free ions. It gives the pathway to move electricity through this solution. The flow of electricity takes place without the decomposition of the substance. Flow of electricity is due to flow of electrons. In electrolytic conductor, flow of electricity takes place accompanied by decomposition of the substance. There is without decomposition, but in electrolytic conductors, flow of electricity will accompanied by decomposition. And here is flow of electricity is due to the flow of ions. So keep in mind there are two different. In metallic conductor, there are free electrons, but in electrolytic conductor, there are free ions which give the pathway to move. So now we will discuss how does electrolysis work. As we discussed the parts of the electrolytic cell, here is a battery, here is the electrodes and electrolytic tank with an electrolyte. So what happened in this electrolysis? Actually, in this electrolyte, there is positive and negative ions or free electrons. When we attach the battery with positive and negative terminal, then what happens? Then negative ions goes to the anode and positive ions goes to the cathode. What happened at anode actually? When negative ions attract to anode, they lose their electron. Anode attach or gain their electron. Negative ions come to the anode, lose their electron and may deposit or become an atom or molecule. These electrons move from positive to the negative terminal and come to the cathode. Here, what happened actually? Positive ion attract towards cathode and gain the electron. So we can say that cations and anions are discharged and the form of atom or molecule. So it is the process of electrolysis that negative ions attract to the anode and positive ions attract to cathode. When we attach the battery with these electrodes, negative ions lose their electron, anode move this electron from positive terminal to negative terminal, and here positive ion gain this electron and may be deposited in this solution or become a gas and release out. What are binary compounds? So binary means two. If a compound containing only two elements, usually metal or a non-metal, this type of compound is known as binary compounds. So here is the example of sodium and chlorine. When sodium ion and chlorine ion comes together, there is attractive forces between them due to the positive and negative charge. They attract to each other and made a compound, which is binary compound because there are two elements are present. One is metal, second is non-metal. Electrolysis of molten sodium chloride. So, molten sodium chloride means sodium positive and chlorine negative are present in this electrolyte. What is electrolyte actually? Electrolyte is a liquid which is present in this electrolytic tank. So, sodium and chlorine moves around and around in this solution. When we attach the battery, then what happened? Negative ions attract toward the anode and chlorine negative. So chloride ion attract to the anode, give its electron, okay, use its electrons and become an element. So in here chlorine become a gas and evolves out from this electrolytic tank. But at the same time, electron move from positive terminal to the negative terminal and come to the cathode. So, sodium have positive charge and attract towards the cathode. So, cathode give this electron to the sodium and sodium after gaining these electrons becomes stable and in the form of an atom, sodium exists in this liquid. So what is the overall equation? Actually, chlorine come to the anode and give the electrons and itself become a gas and evolve out. But at cathode, sodium positive ion gain an electron and become an atom. So her overall reaction in this liquid is sodium chloride in the form of liquid dissolves and broken down into the ions. Then sodium in the form of liquid present in this tank and chlorine become a gas after electrolysis, after passing the electricity from this cell. So after this, why we use inert electrodes during electrolysis? Because inert electrodes do not react with products of electrolysis and the electrolyte. If we use non-inert electrodes, then what happens? So electrodes can react with the product and our desiring product does not obtain. So inert electrons mostly preferable because inert electrodes never react with our product. So usually carbon and platinum electrodes are considered inert because they are rarely involved in electrolytic reactions. Carbon and platinum require a huge amount of energy for reaction or for their. So carbon and platinum are the preferable inert electrons because they never react with our product.